On page 400, we have the Steps to Success Level 2, which begins with a worksheet called SKI, and it has this setup on sheet 1, which has already been provided for us. Here's the scenario. The equipment division is looking into a new piece of equipment to mold skis more precisely than the current technology we're using. Cost of the machine plus installation is estimated to be $1.5 million, which is different from $1.5 million. The projected cost savings are expected to be $10 per pair of skis. So we're going to spend $1.5 million to save $10 on every pair we manufacture. So obviously we're going to have to manufacture a ton of these skis to recoup the cost of that machine. We have been asked to estimate a projected cash flow savings, if any, that will be generated by this proposed project over the next 4 years. So remember those numbers, 1.5 million and 4 years. Number 2 says, rename sheet 1 as cash flow. So let's rename that. Insert the following title at the top, merged and centered, and then we'll start entering numbers. Number 3 says enter the sales volume for each year, assuming sales in year 1 of 140,000 pairs. So we're assuming year 1, the sales volume will be 140,000 pairs. It would probably be nice to put a comma in that, wouldn't it? And we don't want 2 decimal places because that's not dollars and cents. That is just pairs of skis. And we want to increase it by 5% every year. Many ways we can do this, but possibly the easiest way to do it is to say, take that figure, multiply it times 105%, which would be 1.05. The 1 gives me the 140,000, the 5% gives me 5% of it, and together it gives me 105% of it. So this number will be 5% more than that. And 1% is 1,400, isn't it? So 5% should be 7,000. So this should say 147,000, and I don't want 2 zeros on it. And now, if I just copy that formula over, now we want to make sure they said actually round it to the nearest whole number, didn't they? They're all whole numbers until we get to year 4, and we're not going to be making half a pair of skis. So let's use the round function and say round this thing and they want it to the nearest whole number. So that would be 0 decimal places. If we wanted it to the nearest tenth, it would be 1. Nearest hundredth would be 2. But if we wanted it to the nearest hundred, that would be a -2. So we can round it to not just decimal places or whole numbers. We can round it to the nearest $1 million if we want. That would be a -6. So we want this to be 0 to round it to the nearest whole number. And now if we copy that formula over, this is rounded to 68, and I'm going to knock all the decimal places off of that. Number 4 says enter the cost savings as $10 per pair, which will be the same amount every year. We want that to be currency, don't we? And we want that to be the same every year. That machine's going to save us $10 a pair. Number 5 says calculate the cost savings right here. How much are we going to save every year? Well, if we think we're going to make this many pairs and we're saving $10 a piece, then that's going to be multiplying those two things together. So we're going to take the number of pairs times the savings per pair, and this should be our savings in that year. Continuing with the Steps to Success Level 2, at the top of page 401, we're going to borrow this money, the $1.5 million, This is on our loan sheet. $1.5 million, annual interest rate of 5.25% for 4 years, equal installments monthly. So, first of all, and we're going to pay it all off, ending value 0. We want to find the cumulative interest expense for year 1 right here. What is our cumulative interest expense in year 1? Assume the loan will start at the beginning of year 1 and all payments will be made at the end of each period. So we want to be able to copy this formula over and find these values for years 2 through 4. Here's the key. In year 1, we're going to start at period 1 and end with period 12. In year 2, we're going to start with period 13 and end with period 24, just the 12 months in year 2. In year 3, we're going to start with 25 and end with 36. And in year 4, we're going to start with 37 and end with 48. There's 48 periods, and we just want to know what's our cumulative interest during these first 12, the next 12, the next 12, the next 12. So here's something that'll help you. If you want to know the start of the period, you go to this thing. That's C1, isn't it? And if you multiply it by 12, it gives you the last period in that year. If you subtract 11 from it, it gives you the first period in that year. So the first period in year 1, that should have been C2, shouldn't it? The first period in year 1 is 1. If we say now go check 2, the first period in year 2 should be 13, shouldn't it? And it's 13. The first period in year 3 should be 25. We've just had 24 periods in 2 years, so this should be 25. We've had 36 periods in 3 years, so the first period in year 4 should be 37. So that's how we find the first period of each year using the year number. To find the last period, we just take the year times 12. So here, we would just take C2 times 12. And that says that's the 12th year. We don't want it as currency. We want it just as a plain number with no decimal points. So that's the last period of the year, and we should get 24, 36, and 48. So the first year we want to know what's the cumulative interest for periods 1 through 12, then 13 through 24. So that's kind of a little numbers game that we need to understand what's going on there so that when we write the main formula, that will make sense. So our interest expense, we can use the cumulative interest payment, and that is CUMIPMT. It returns the cumulative interest paid between 2 periods. So you can pick the length of a loan, say how long it is, and etc. The first thing, we want to know the rate. What is our rate? We are borrowing the money at 5.25% interest, aren't we? So that equals this thing right here, doesn't it? And I'm going to make that absolute, because I want that to stay the same all the way across the board. Now I type a comma. Actually, that's the interest rate per year, isn't it? I want the interest rate per period. So I have to divide that by 12, but I'm going to go ahead and make this the 12 because I might change that later and I won't have to rekey it. And that's going to be absolute. Now I type a comma and it says, what's next? I want the number of periods. The number of periods, total number, would be the number of years times the number of periods per year. So that's going to be 48, comma, what's my present value? How much am I borrowing? I am borrowing this original loan right here, am I not? So I'm going to make that absolute. My start period, this comes from the cash flow sheet, doesn't it? My start period is going to be these formulas right here that we did. My start period, I'm in year 1 right now. So I want to take that thing times 12 minus 11. It's going to multiply by 12 and then subtract 11. And I want that always to go to row 2, don't I? So I want it to copy across. I could make that absolute row 2, but it doesn't matter. We're not going to copy it down. Actually, I think I will make it absolute row. That's my start period. My end period is just going to be that thing times 12. And I'm going to pay it at the end of a period, which is a 0. When I take my extra equal sign that I had in here out, that gives me, that's how much I'm going to pay interest the first year. It would be nice to format that as currency, wouldn't it? Now I can copy that formula over, and I should be paying less interest every year, shouldn't I? Because I'm paying that loan off. So I've got less interest the second year, less interest the third year, and even less interest the fourth year. Number 8 says calculate the depreciation for this equipment using the straight line depreciation method. The equipment is assumed to have an 8-year life with a salvage value of $50,000 at the end of that period. For cost, use the cost of the machine plus installation. Set up a separate worksheet named depreciation to store these values. Use named ranges. So on the depreciation sheet, our cost is going to be the $1.5 million that we are borrowing. Our salvage value is $50,000. The life is 8 years. And notice we have named those cells salvage, capital, and life. So if we go back to the cash flow sheet, we want the depreciation using the straight line method. The straight line method is SLN. It says that returns the straight line, S for straight, LN for line, depreciation of an asset for one period. The first thing it wants is the cost. Well, the cost is right over here, isn't it, under capital? And the next thing it wants is salvage, which is this number. And the next thing it wants is what's the life of that machine in years? That's the life. And it goes back to our original sheet and it says that's your depreciation. Now notice this is a positive number, and we really want it to be negative because it's depreciating. That's money we're losing, money that's going away from us. So we can simply put a negative sign on the beginning of that. And let's do it as this. Notice the difference. With accounting, it puts the dollar sign at the very left hand. With currency, it does the dollar sign right next to the amount. So we're going to leave that accounting, and if we drag that over, it should be the same amount every year that depreciates over the straight line. Number 9 says calculate the net cost savings. Net cost savings per year. Well, we're saving this much per unit that we produce, but it's costing us this much in interest and this much in depreciation to do that. So if we sum those three numbers of here's how much we're saving, but then we have to deduct those two things, then we're only saving 1.1 million instead of 1.4 the first year. And if we copy that across, every year we're going to save more, aren't we? Because we're paying less in interest. Our depreciation is the same. And after 8 years, this machine goes away. It's no good anymore, or that's our estimate. I suppose since these are to the nearest penny, we should make these to the nearest penny. Number 10 says, calculate the additional tax that would be owed based on the net cost savings. In other words, this is going to be income to us, that the zone is taxed at a 35% rate. use a global named range to store this value. We could store this value anywhere we want. Seems like the depreciation sheet is as good a place as any because that's where we're storing some other values. So I'm going to call this cell tax rate. Actually, that doesn't name it, does it? We're going to make it 35%. It's this cell that we're actually going to name tax rate. So I'm going to name that cell tax rate, and in that way, if the tax rate changes, I just change it here and all my formulas update. So if we go back to the cash flow worksheet, the tax we're going to owe is going to be this amount times that tax rate, isn't it? So we're going to owe this much extra tax for this year, and we're going to owe those amounts in coming years. And tax dollars never come toward us, do they? They always go away from us. So we really do want this to be negative. So let's make the first one negative and then copy it across again, and these amounts will all be negative. Number 11 on the next row says, calculate the savings after taxes. Well, here's our net cost savings, and here's the taxes. So if we add those two together, since the taxes are negative, we will just say this thing plus that thing. So our net cost savings would be this amount. Number 12 says, complete the worksheet adding back in the depreciation that was deducted. So here's the depreciation. We're adding back the depreciation in row 15. So we're simply going to take this and change the sign on it, aren't we, to add it back. So I'm just going to say equals the opposite of what's in cell C9. So that adds back the depreciation, and I can copy that over. We're also supposed to add in the cumulative principal payments for the corresponding year. We already did a cumulative interest payment, didn't we? And this is referring to these absolute cells, and it's referring to the year number in row 2, but with the column relative so we can copy it over. The cumulative interest payment, notice what are the parameters? Rate, NPER, PV, start, end, and type. And now we can copy that formula to the other columns, and that is subtracting the principal that we're having to pay on the loan. The rest of number 12 says we want to arrive at a final projected cash flow. So it's this savings plus the depreciation added back because we're not actually having to spend that money, and then we subtract our principal payments. So we're basically going to sum those three things: the savings, the depreciation that we're not actually spending cash for, and we are spending the principal payments on the loan. And so there is our projected cash flow estimate, and we drag that across to complete the table. Number 13 says, skipping several rows under the data, include a sentence summarizing whether or not the cost of this machine will be recovered based on the projected cash flow estimate over the 4 years. So, how much are we spending? $1.5 million. What is our projected cash flow estimate over the next 4 years? Let's sum that. So we'll do an auto sum here, and it picks all those things, and it says our projected cash flow is $2.5 million, and we are borrowing $1.5 million. So this is our projected cash flow. We borrowed $1.5 million, so we might say something like projected cash flow of this amount is greater than investment of 1.5 million. And we're supposed to highlight that in blue. One caution. This looks really good on paper. Oh man, let's go out and borrow $1.5 million. But as we said before, when you borrow money, you are presuming on the future. Nobody knows what the future will bring. We're assuming we are going to sell 140,000 pairs of these skis this year and that we're going to increase by 5% every year. That might not happen.